Hi, everybody. Hi, everybody. Welcome to our presentation today. We are beyond the structure, warehouse, and industrial office design. We're just about to flick over into the 12:30 and we will be recording this presentation. So we're just giving it a moment for everyone to sort of load in as it does at the beginning of presentations. And then we'll kick off. So we'll be recording. You're going to get a copy of this presentation sent to you today as well. And we'll have Q&A at the end of the presentation for our presenters. So let's get stuck into who are our presenters today. I'm actually going to hand over, we've misadvertised. I am not your presenter. We're going to hand over to Jen Zarnock from Roof Logic and Candace Smith from Kingspan Thermocraft. So I'll hand over to those. They'll do a short introduction, then we'll get stuck into our presentation today. Thank you,
Oh,
ladies.
thanks for that, Victoria. Just a very quick thank you for having us, team. I've only been with Roof Logic for just under 2 months, so this will be a really good test run for me. But very briefly, for those who are not too familiar with Roof Logic, so we only offer warm roof solutions, so we don't sort of dabble with any cold roof, and we'll distinguish those later in the presentation. But sort of large warehouse type buildings are pretty much our bread and butter. However, we don't shy away from bespoke projects such as a recently completed Te Kaha Stadium in Christchurch, founded by Graham Tennant with extensive experience in roofing back in 2014. Graham brought a number of warm roof solutions backed by scientific research and overseas track record into New Zealand, and we'll talk about those shortly.
Thanks, Jen. It's lovely to have you on here today. I'm Candace Smith. I'm the National Specification Manager at Kingspan Thermocraft. I've been happy to be in the business for a little over 4 years now. I am going to apologize in advance if my voice is a bit scratchy and nasally. I have been fighting winter ills and chills this week. My job, along with the rest of my specification team, is helping architects and designers to turn your design intentions into compliant, high performance buildings. Should we kick off, Vic? Designing for mixed-use buildings requires careful consideration of the functions of those spaces. In the example on screen here in the far right-hand corner, the office shown there would be a lined and insulated space. In some instances, due to orientation and site restrictions, it can be challenging for a cold roof to be successful. Considerations would be whether the office building would get enough solar heating and ventilation, both of which are required to activate drying in a cold roof. The warehouse pictured on the left, this roof design needs to be considered in relation to the operation of that space, and we will dig into those topics throughout this webinar. It could potentially be a cold roof uninsulated design. Those warehouses tend to have large roller doors, which are kept open often for the majority of the day as people and trucks move in and out. That combined with the height of the roof tends to allow ample ventilation. However, depending on the use of that space, the warehouse could need to maintain a certain temperature, in which case we'll be talking about a warm roof design, which I'll hand over to Jen to talk us through.
Thanks for that. It's a great sort of lead on in a way. So this is a great example of a generic warehouse cold roof design. So you've got direct fix into a steel purlin. Some cases could be timber purlins, but fairly uncommon. You've got mesh or netting, underlay, and then your pre-painted steel, roll-formed steel. Of course, instead of the underlay now, you've got products such as Drydex or Fleece Coat that are fleece-backed pre-painted steel. Now, this is very, very common in a manufacturing facility where thermal control of or thermal performance within that building isn't a key factor. This roof offers you all of the E2 requirements. It keeps the rain away, but it's does very little for controlling those internal temperatures. Now, of course, with a warm roof, this is a really great example. This is actually a New Zealand Post distribution centre in Wellington, and it really clearly gives you all of the layers within a warm roof built up. The distinguishing factor, and at Roof Logic, we're a little bit funny with the term warm roof because it very seriously simplifies what it really is and all the features and benefits. But and we prefer the term externally insulated vapor controlled roof assembly rather than a warm roof. And what makes a warm roof is really incorporating a vapor control layer where you're keeping two environments separate, internal versus external, and you're also adding a continuous insulation blanket on top of your roof, thus moving the dew point onto the outside of the building rather than allowing for the dew or moisture or condensation happening within the internal system. So on the left-hand side, far corner left-hand side, you're looking at what is the start of our warm roof system, a liner deck, which is the basis for the built-up. Once the liner goes in, it becomes your weatherproofing, and you're actually able to carry on all the works underneath the roof. So the workers are feeling safe and the work can carry on. On top of that liner deck vapor control layer, there are variations of systems. In this case, we then install a post and rail system that allows us a cavity for insulation to go in. And then you've got the top metal skin, we call it, available in a variety of profiles. In terms of insulation, you can utilize, from glass wool to stone wool, but you similarly can utilize a PIR board type insulation. Now, when we are talking about a warm roof versus a cold roof, we're talking about the assembly actually moving the dew point to the outside of the building. And this is a really, really great example of a warm roof versus a cold roof assembly. So left-hand side, warm roof, right-hand side, cold roof. This building was... on the right hand side, the original is actually a recover system. So we got called in post the completion of the build. The building has been operating for about two weeks, and they were getting some very serious internal condensation. This building was used for archives, storage, and office space. And the original build up was suspended ceiling, insulation, cavity, and then you've got the standard cold roof solution. So some very serious condensation problems. The tenants were actually had to evacuate. So we got called in and we built on a warm roof solution on top of that original structure, ultra-therm with PIR board insulation. And you can very clearly see this is a sort of a warm morning. You can see the condensation forming on the outside of the building on the left-hand side versus the right-hand side where there will be condensation but will be somewhere within the internal environment. So why consider a warm roof solution? And you've got really the main reasons to why you'd consider it is you've got you want to achieve a controlled thermal performance, you want to mitigate any risk of condensation, you want to give your building a bit of durability and energy efficiency. And as a matter of fact, you want to provide a multi-tenancy case. So if you're not an owner, operator, or an occupier of the building, you want to secure longevity of your lease, right? So you want to make sure that it's suitable for a multiple of tenants. So providing a better, smarter roof system actually ensures the longevity of your tenancy. This was a really, really great example of sort of a number of considerations before going with the warm roof solution. So this particular, we actually did a case study on this. This is a Canterbury Linen Services building. Originally was designed in insulated panels, and the particular case for this is the internal environment is essentially a breeding ground for potential massive condensation issues. So these guys process around 150 tons of linen weekly. That means they wash it, they dry it at very high internal temperature and very high humidity. So for all of the Roof Logic projects, we offer hygrothermal analysis before we sort of kick off when we're doing the specification. For those of you who don't know what hygrothermal analysis is, because I didn't until about 2 months ago, it is an analysis of how temperature and moisture travel through the building and where they accumulate. So we've done the work, all the scientific, the data analysis, and then as we built the system, we actually installed moisture meters and temperature meters throughout the system built up. So we were then getting real life data that we were able to compare to our analysis that was done prior to the start, and those two made up spot on, really proving that there is no condensation risk within that built up system. So yeah, very, very good case study for us in terms of meeting up science and real life performance.
That is a great case study, Jen, and I'm sure in that Canterbury environment, there's a lot of fluctuations of temperature, which I can attest to being based in Christchurch. So unlike your example, what you're looking at here is our own factory and warehouse in Auckland. You can see some cover tech in that bottom image. In this instance, we have no high vapor producing activities going on. We've got large roller doors, which are almost always open, very little reflected UV, and no requirement, unlike the laundry, to have a specific operating temperature. So often logistics, distribution centers, workshops, and gyms have similar requirements, making a cold roof design with a non-absorbent foil underlay a cost-effective option. Speaking of foil underlays, Kingspan Thermocraft manufacture three variations of foil underlays. All are suitable for unlined applications. First up, we have a Thermobar 397. This is a synthetic foil, which is recommended for our larger unlined warehouses, those that would be subject to less reflected UV. 397 has got a nice clean facer that offers high reflectance values at 75 to 85%, which results in a nice clean finish to both the roof and the walls. Thermobar 344, on the other hand, is a true aluminium foil. This makes it a great choice for our smaller builds where we have potential for higher reflected or indirect UV. 344 can be installed white face or foil face down. It does have a slightly lower light reflectance property than 397. Bear in mind it is a true foil, which means it is electrically conductive, so naturally care must be taken when installing it. Both of these products are fire retardant and self-supporting, although we do recommend the use of support, something like Osmesh, which I'll get to a bit later. Neither can be used in canopies or under translucent roofing. We do see that from time to time. Both can be cut to length, and that is a great opportunity to reduce waste on site. I'll introduce a new product that maybe some people haven't seen before, Air Cell Insuliner. This is great for projects where excessive heat gain is a concern. Insuliner is our 3-in-1 vapor and reflective barrier. It could be, excuse me, Air Cell reflects up to 97% of radiant heat away from its surface. So it's often, it could be considered for just certain aspects of a project. A good example is Mitre 10 in Wanaka, where Air Cell is in the drive-through section, and then the rest of the warehouse has got Thermobar 397. Like the previous two, it can be used on roof and walls. I just will note before I move on that it is not to be considered as a substitute for a warm roof, where a warm roof design would be more appropriate. Osmesh is our superior quality underlay support and fall safety mesh. Can be used on a variety of commercial projects. We often see it being specified into warehouse applications. It complies with AS/NZS 4389 2015 as a fall arrest. The coating, which is to that WO2 standards, is the lightest grade coating, and that has a requirement for 35 grams per square meter of galvanization. That means that Osmesh can be used in confidence in protected locations, such as the interior of a warehouse, for example, or very low exposure environments where it can be expected to last for up to 50 years per B2. It cannot be used in exposed applications such as canopies because there's just insufficient galvanization for long-term durability. Thanks, Vic. Let's look under the slab. So as we know, warehouse slabs are often subjected to very heavy loads, whether that's from the weight of the goods stored in the warehouse, accommodating forklifts and huge trucks in and out. We've got you covered for your damp-proof membranes. with thermothene orange. At 300 microns, it's a very heavy duty, highly tear resistant brands appraised option. On the other hand, where insulating the slab is required in the likes of a cold store or temperature controlled environment, GreenGuard XPS GG300 is a great choice. At 300 kPa at 10% compression, it's durable, high performance, and also compliant tested under 4859.1 2018. In the first images, we looked at an attached but a separate office. In warehouse applications, we often see more creative office spaces being employed, like this image here on the left, a box within a box approach. We sometimes see them stacked in a corner, maybe on a mezzanine level for visibility into the operations. The importance here is each approach carries different implications for the structural design or the acoustic separation, even the thermal performance where roofs are being shared or not shared, the requirements for natural light, and the day-to-day experience of the people who may work there. Choosing that right configuration depends on the nature of the business, the size of the workforce, and how closely the people work in the office need to potentially interact with warehouse staff. I'll hand back to Jen to discuss the advantages of warm roofs in the office spaces.
Thank you. Thanks, Candice. So this is sort of a diagram we use quite often, and a bit of a comical way, I guess, of explaining the difference between what insulated cold roof and a warm roof, sort of how they differentiate in performance. With cold roof in an office space, you're quite often it is an insulated space, so it could be a suspended ceiling insulation type of a scenario, cold roof assembly, but you are heavily relying on ventilation to manage any of that condensation risk, right? So you're managing the risk by making sure that you've got sufficient ventilation. And of course, when it comes to ventilation, $1 million question is, what does it look like and how much of it is actually required? If you're working with, I don't know, 30-meter sheets, what's the pull-through ventilation, required to manage any of condensation accumulation in there? So going to a warm roof for an office built up, you are, as I've already touched on the differences, you're essentially separating the two environments. You're separating the warm internal environment from the cold external environment. The vapor control layer acts as there's no exchange of vapor. And of course, the insulation layer is acting as a thermal control layer, so a continuous thermal cover. So instead of putting in ventilation and sort of colliding and hoping for a good result, you can go to a warm roof solution where we absolutely guarantee that there will be no condensation or accumulation within that system. Thanks. Vic, next slide. The couple of factors that you're considering, especially in a warehouse and adjoining office environment where they to go to a warm roof solution, is a couple of factors, location, exposure to natural sun, and its orientation. Is it actually going to get enough sunlight? Is the design allows for sufficient ventilation? And this is a Vitico project where you can see the office is elongated, it is fairly shaded, and it backs right onto the warehouse space. So in this case, both the warehouse itself is done in a warm roof solution, but the office as well. And it incorporates all of the features and benefits of a warm roof, controlled environment, and no condensation risk. And of course, we can incorporate acoustic performance. We've all been to an office where you're having to speak louder and louder and louder, especially when you've got a office full of salespeople. Guilty, and you're having to mitigate the sound reverberation. And aesthetically, you want a nice office environment. So incorporating acoustic features into your warm roof system will allow you to achieve higher acoustic performance. So going to, instead of using a liner deck, which is your essentially trapezoidal corrugated, trapezoidal roll form sheet, you can go to a perforated version. Going to a perforated liner as your base or a cassette tray can increase your noise reduction coefficient to 0.75 with a liner deck and as high as 0.95 with a perforated cassette tray. Now, for those of you, and I've recently had to learn all this, noise coefficient, of course, 0 is when all the sound is reflected back to you, and 1 is when all of it is absorbed. So within a warm roof system, you actually can build up that acoustic performance. We've also had all of our systems tested for rain noise attenuation. So at a 40 millimeter per hour rain downpour. Now, this is a 1 in a 10-year event, right? We are talking a massive downpour. It sounds like a chainsaw going off. So what you actually hear on the inside, if you've got that warm roof structure, is, sort of the sound of aircon, humming in the background, right? So it's not abrasive. And of course, sound transmission loss. So this is how much the building materials allow noise to come through. So our systems on average will decrease that sound by about 43 decibels. So acoustically, you can incorporate that performance. This is a great photo and I love it. So this is an example of a Hawke's Bay fire station office space. It incorporates our perforated liner, and you can see that is the ceiling, right? So your warm roof is perforated liner with the built-up system on top of that, and that is your ceiling. So these guys didn't have to go to a suspended ceiling or acoustic baffles. All of that was taken care within that warm roof built-up, and aesthetically, I think it looks pretty bloody neat. So very quickly, Roof Logic offers a number of warm roof systems. So we vary between something like an Ultratherm with a PIR insulation, Fibertherm post and rail, a structural post and rail with glass wall or stone wall insulation. You've also got a number of solutions with the membrane skin, and you've got a number of solutions in our recover system where, as I've already mentioned, we built onto our original roof structure that perhaps either at the end of its life or has failed or needs some adjustment. We can offer tapered insulation solutions where perhaps the pitch of the roof needs to be adjusted for various reasons. But because of such a massive variety of the systems and the benefits and the features that they offer, we really strongly encourage architects to get in touch with us as early as possible so we can work through with you on the best solution for you. I've already touched on all of our projects come with hygrothermal data analysis. We offer structural design. Our systems are warranted. There are warranties for them. And we offer a pretty quick compliance back. So rather than taking on the risk of designing a system that carries a potential risk of condensation, come to us, have a chat to us early. We'll work with you on your requirements, and we'll take the risk out of your process completely.
Well, thanks, Jen. That was super. As we sort of cover off or finish off on the roofing section, we'll now look at some simple high performance solutions for concrete walls. In this section, I'll introduce 3 Cooltherm solutions for concrete walls, and I will hold up my little samples here. So, I've even got them wrong around. K12 is a foil board. K17 is our insulated plasterboard. I wonder if you can see that nicely. It does have 10 mil of jib laminated to the phenolic core. And then potentially a new one for some people is our K20, which is difficult to see on the camera, but that is a phenolic core with a tissue backing. That one is used particularly for concrete sandwich panels. All 3 of these options are alternatives to strapping and lining with timber and bulk insulation. K12, as you can see on this image, is installed continuously against the concrete with the use of a clip and channel system or a timber batten. That allows a choice of wall lining material, depending on whatever the nature of the wall is, while creating a service cavity. You can't really see it in there, but you can adjust the size of that service cavity. K17 can be installed directly onto the concrete wall, either just using mechanical fasteners or a combination of mechanical and construction adhesives. As K17 has plasterboard pre-applied, it's a one and done solution. Installing either K12 or K17 means less labor time and costs when compared to strapping and lining with bulk insulation. Let's have a look at what that saving could be. So Colliers New Zealand estimates an average weekly rental of $556 to $615 per week per square meter for prime rentals in New Zealand. Excuse me. Wellington takes the cake with prime rentals at $770 a square. So every bit of additional space that we can give back to the rentable or saleable floor space means extra dollars for your client. What we'll do next is we'll compare strap and lined option, K12 and K17. In all of these examples, I'll use a base of 110mm concrete panel, which you can see on screen. And because I'm based in Christchurch, we'll use thermal performance and condensation risk modeling in the Garden City. So this scenario on screen now, we have bulk insulation of R3.4 between 140mm timber studs. This results in an overall wall thickness of 260 millimeters, giving us a construction R value of 2.7. The modeling shows significant condensation, which peaks at 1.5 liters per square meter in July. With condensation present 8 months of the year, it's a bit of a concern. The total floor area we end up is 42.47 squares. So what happens when we switch to K12 on clips and furring channels? In this example, we'll use 60mm K12. That bumps us up to a 3.26 construction R value, so a nice chunky R value with a slimmer wall at 196 millimeters with no condensation issues in that build-up. The total floor area results in 44.27 square meters, which gives us an additional 1.8 square meters over the previous example with the glass fiber. If we use Wellington as an example, that's an extra $1,380 per week in rent. I've thrown in a little what not to do here. This was a project in the South Island. It was a retail project. K12 was specified with clips and furring channels. I got to site, as I often do, because I love going to see your designs and our input in action. I was aghast to see that the contractor had spent countless hours framing out that wall, then having to cut and friction fit the insulation in between each of those little gaps. What this results in is increased thermal bridging, increases the wall thickness, and it significantly reduces the thermal performance of that wall. But I am digressing, so let's get back to K17. We've got the same 110mm concrete panel. In this instance, we've used 60 mils of K17 insulated plasterboard. So that's 10mm plasterboard, 50mm cool therm, directly fixed to the wall. We get our slimmest wall at 170 mils thick, an R3.37 construction R value, so it bumped up a little bit more, and no condensation issues. The total floor area is now 44.45 square meters, which means almost 2 square meters over our first example with bulk fiber. And I'm going to pick on Wellington again, $1,500 odd extra a week for Wellington. K17 would be our go-to when there are a limited number of services required on the wall. One could potentially mix K12 for those walls that have heavier service requirements and K17 on the other walls. Thanks, Vic. And finally, K20, our tissue faced phenolic foam. This one is designed to be sandwiched between concrete panels as part of a system solution. Thermomass is one such solution. Our K20 boards are sandwiched between 2 layers of concrete, and they're secured with thermomass pins. These pins and their placement provide securement of the layers, so the 3 layers together, and the placement and frequency and thickness of those pins are all balanced with the seismic requirements of the project. So that's all designed by Thermomass. Te Papa Biodiversity in Wellington is using this system at the moment, and it's a perfect use case for the K20 Thermomass. The panels are manufactured off-site, so it's reducing that on-site labor and simplifying the build sequencing. Combining the insulation with the mass benefits of concrete, these systems can contribute to overall thermal stability by reducing the temperature fluctuations. And in this project specifically, it's housing temperature sensitive objects. So combining this, we get a low maintenance, high performance wall. We're also seeing an increase in the demand for K20 residentially, where clients are going for a concrete aesthetic. At Kingspan, we're all about better buildings for a better world. So we've covered off thermal comfort through designing high performance roofs and walls, and we should not forget the importance of acoustic comfort. For instances where clients may be after a different aesthetic to the perforated liner deck or cassettes that Jen mentioned, or maybe looking for wall treatments as well, we have two options. Troll deck, which is our wood wool panel. This gives us a group 1 internal lining rating and a natural material appeal. Fibertech is our polyester backed MDF panel with a group 2 rating. Both products deal with reverberation, so that's that NRC rating that Jen was talking about earlier. And both just help to create quieter, calmer environments. And we can certainly attest to that within our own facility. When we have our sales get together, we've got 10 to 12 salespeople busy chatting. Installing our troll deck into our boardroom has made a heck of a difference. Thanks, Vic.
Oh, this is me, isn't it?
Oh, it's you.
We flew through this one.
Yes.
I guess in summary, look, design of industrial or warehouse type buildings, especially when you've got adjoining offices, can be quite a complex beast. And there's a number of considerations that you'll have to, go through for design of the warehouse versus the office. And you could actually utilize a number of roofing solutions to fit the specific need of that building use. If you are considering a warm roof design, however, warm roof design will eliminate any condensation risk within your building. You will provide a better thermal performance within that building once again, and certainly will incorporate acoustic performance. So as compared to a cold roof, as an example.
I'll take the wall ones then, shall I? There are a variety of ways to get maximum lettable or saleable floor space using cool therm on concrete walls. Using these systems is not only easy to install, but offers greater longer term durability and thermal comfort, which, as Jen mentioned, is really highly important. The use of acoustic treatments has been so underplayed. It really is vital in creating office spaces that are calm and sort of encourage a productive environment. I think that might be us.
Mm.
Thank you. That is us. And if you'd like to learn more about either RoofLogic or Kingspan systems, we have a QR code here that'll take you to a page that enables you to just pop a query in, and we'll direct that to either a RoofLogic team or a Kingspan team and address your query. But we do have some questions online if we're going to curate those. We've got one about a dew point of the K17 example. And I'd say the technical team, just like RoofLogic, technical at Kingspan Insulation, does hydrothermal analysis and dew point analysis, solar thermal construction R values for a project. We'll always model your wall for you, specifically for your both internal use, your climate, and the elements that are in your build. So the phenolic insulation is a vapor retardant insulation, so it performs very differently instead of a vapor open. So we'll often find that there is not a dew point against a concrete wall, but we like to model it. We like to give you that compliance for your project for council as well. So get in touch and we'll model your project for you there, Stuart, as well. We also have a question, I think, when we were talking about the RoofLogic with the perforated liners, we had a question about the vapor control on that, Jen. Can you just talk us through the build-up of that?
Maybe could you go back on the slides as well, maybe just to show the vapor, the built-up might be helpful. I'll do my best.
Oh, we've gone too far. Hold on. There we go.
One down. So yeah. So this showcases a perforated liner and a cassette liner. You will have your your insulation infills, or it could be an acoustic infill that will go into the pans of the trays. You then have got a vapor control layer that will go above, sort of going over the ribs of the profile. So this is your essentially standard, trapezoidal profile. And if you can see in line with the liner deck render. This is our fiber therm X post and rail system, and the rail is actually installed on a little pedestal. So the rail sits on top of a pedestal. The pedestal goes in, vapor control layer goes in. Then you've got the post installed onto that pedestal. So there is a continuous vapor control layer through that system.
Excellent.
Yeah,
Thank
so
you.
it doesn't follow the ins and outs of that liner deck, or sorry, that perforated liner. But yeah, there's all of our systems incorporate. And in the cassette tray example, you've got an acoustic board on top of that cassette profile. You've got your insulation acoustic board. Then you've got your vapor control layer that goes over that acoustic board.
Absolutely. And building up for acoustics is important. We've got heavy rain where I am in Auckland today, and I can hear it on the office roof where we are. We're a box within a box, but I can still hear the rain on my roof. So acoustic would be great in that instance as well for that sound transmission coming through.
And you can still certainly build it up with various other layers as well. So just depending on what requirement you've got. Yeah.
On that front. Great. I have a question that was asked outside of this presentation, but I'll bring into this presentation about the speed of installing with CoolTherm. Candice, have you got some stories with us about yeah, thank you. I know you've got installers. Installing your office wall with CoolTherm.
Well, I love to go to site, and I went to a project just recently. Can't share photos because their client has asked us not to, but it was hundreds and hundreds of square meters of K12 installed. We rocked into site, and the installers were very pleased to tell us that it had taken them a whole 2.5 days. When I do get permission to share that, we will share what that actually looks like. Another one here in Christchurch was using K17. I went on to see old mate on his cherry picker because it was probably 3.5 meter high tilt slabs. Very pleased with himself because he'd saved 2 days installing insulation on that just using K17. So they just construction adhesive on the wall, a couple of mechanical fixings to hold it in place, and very chuffed with themselves. We are looking at measuring actual data, but as projects vary project to project, roof heights, stud heights, all sorts of things, it's difficult to get a one and done answer for you.
About how fast you can install from one
About how
project
fast.
to another. Yeah.
Correct.
Not quite as simple as when we look at, say, insulating a car park roof with either glass fiber or our CoolTherm product there. We can very clearly draw a comparison between the speed of installing CoolTherm there because it's much lighter lift as well. We haven't talked about that in this presentation because most of the buildings we've been dealing with have been single level. We don't seem to have very many questions on us today, so I think you guys have done a fantastic job about presenting out with our topic. I'll take us back to our last page there. So if you do have any questions that you'd like to learn about these systems in particular or how they might relate to your project, just get a hold of us at either RoofLogic or Kingspan. Both our technical teams would be happy to support, and our service offer is very much the same: bespoke, project-based advice offering thermal performance calculations, dew point analysis, hydrothermal calculations, and specific advice about your design commentary and details. Thank you very much to Jen from RoofLogic for joining us today, and from Candice, our National Specification Manager, for Daniel Marshall, who's been running the background, putting some links up for us as well. We appreciate it, especially when we've been running this from very different places, all of us today. So we today are an advancement of modern technology. So we're feeling quite pleased with ourselves. Thanks very much. We'll
Victoria. We've just got one last question coming.
Yeah.
If you want to grab that, Shannon has sent a lovely question about some K17 in the Q&A. Just when using K17 in a warehouse type space with precast wall panels and steel portals, how does the K17 fit around the steel portal legs?
Precast panels and steel portals, how does K17 fit around the portal legs? No, thank you. Normally we would actually look at a specific detail and see how that's going to sit around, but if it's going direct fix, it can be a combination between how the fire engineer is fire protecting that portal leg, what we need to do in that space. The K17 is very easy to cut and fit around any aperture that you need to accommodate. The phenolic can easily be cut with a Stanley knife, the jib with a normal skill saw, so on to cut the jib as well. So it's a very easy product to manipulate. I should say as well, if you do have to run electrical through it, the phenolic insulation will not damage electrical cabling as well. So again, a very easy product to install. But perhaps, Sharon, we might just get in contact with you, look at a specific detail and provide some specific advice about how that might be built around. There might be some other elements there we need to consider. I don't think I've got anything else. There's one that says, have we done any hydrothermal modeling? But I think there might be a relation to one of our particular models. And again, we will model and RoofLogic will model your project specifically because every project's slightly different. So we want to be specific for your project each time. All right, I think that's us today then. Thank you so much for your time. Thank you, Candace, for going through. I could hear your voice cracking. It's doing well. All right,
Paper
see you
drop.
all and thank you, everybody.
Thanks, team. Have a good one. Bye.